Thank you for that introduction, Chair. Good afternoon, everyone. I am Awodo Magingi from the Department of Water and Sanitation. I'm going to share a bit of information on one of the activities that we have conducted in a research project called Manage Aquifer Recharge in South Africa. So we try to basically link the groundwater dependent ecosystems in the Manage Aquifer Recharge study in the West Coast. So just a bit of background on the research project, the Manage Aquifer Recharge in South Africa. It is a collaborative research project between or amongst these institutions, the Geological Survey of Denmark and Greenland in Denmark, us, the Department of Water and Sanitation, the University of the Free State, University of the Western Cape, and Rambøll in Denmark. And the project is a Danida-funded project. We were basically looking at 2 study areas, and it's coming to an end now in end of November. So the main aim of Manage Aquifer Recharge in South Africa was to develop MAR technologies that allow for a broader span of water resources to be used for MAR, specifically looking at salinity limit for source water to be used for MAR, and that is linked to Berg River. And then also the types of pre-treatment methods that should be introduced to make degradation of certain compounds more efficient, and that is linked to the second study area, which is the Atlantis. Oh, I was hoping this would be visible. But okay, we do have some MAR sites in South Africa. That's supposed to be MAR sites in South Africa. However, for this specific study, I am going to focus on the Langebaan Road aquifer, which is one of the MAR sites that's in the feasibility stage. And the other study area within this Managed Aquifer Recharge project is the Atlantis, which has been operating for over 40 years now. So again, on the background, the study consists of a number of work packages. But for the interest of this presentation, we're going to focus on work package 2, which looks into environmental effects of MAR applications. And the main aims and objectives of that, linking it to the groundwater dependent ecosystems, is basically to look at the potential ecological impacts of MAR on groundwater dependent ecosystems. And how do we actually assess this potential ecological impacts without even knowing the groundwater dependent ecosystems that we have. So the basic first thing that we did was to look at the status, identify the groundwater dependent ecosystems, and also look at the status of them, trying to find baseline conditions, and also looking at the risk assessment. And also part of this project, we looked at the suitability or the best option, which is the source water method for MAR in West Coast. But linking that to now the groundwater dependent ecosystems, we have to develop a monitoring protocol for wetlands, pans, and other groundwater dependent ecosystems. And then again on the study area, like I said, that I'm going to focus on Langebaan Road and not necessarily on Atlantis. It's part of the 4 aquifers in West Coast, located at the Saldanha Bay local municipality. It receives wet winters and dry summers. And then just briefly on the geology and the hydrogeology of the area, the geology consists of mainly the calcareous sands and calcrete, and with the hydrogeology, it consists of 2 main aquifers, the upper unconfined aquifer and the lower confined aquifer, separated by an aquitard between the 2 layers of these aquifers. So there's a clay layer that actually serves as an aquitard between the 2 aquifers. So we have identified our groundwater dependent ecosystems. So we identified 11 wetlands. And from those 11 wetlands, we did wetland classification and risk assessment index. And I will explain why we basically chose this type of index. And then we also identified 4 from the 11 to do sediment column tests. And also we did hydrochemical analysis in all the 11 wetlands. So I'm just going to go briefly in each of these components of assessment. So with the wetland classification and risk assessment index, it's one of the user-friendly index, especially for non-wetland specialists. It was developed by the University of the Free State by Prof. Paul Oberholster. So we have done quarterly monitoring of those 11 wetlands, looking at pH, EC, dissolved oxygen and temperature as field measurements, also looking at the physical now characteristics of the wetlands. And with these parameters, we have taken them from 4 areas within each wetland. So for example, in this wetland, would have to basically identify 4 points where we are taking these field measurements. And then using this field sheet, you basically record everything on the field sheet. With the results now, you basically punch whatever you got from the field, and it gives you a category of the wetland, the status, and most of the wetlands, they were on category C and some on category D, which basically means that they are moderately to largely modified with a massive loss of natural habitat. And then if we look at the summary, these are all the wetlands. I need you to actually take note that all the wetlands that we found dry at the field, we couldn't classify them. And I think that's one of the gaps of this wetland classification index. If there is no water, then you cannot classify it. And then now, moving to the second component of the assessment, it was the sediment column test. We did this at the University of the Free State, where we looked at 2 wetlands, wetland 5 and wetland 6, that are actually on the Beg River floodplain, and then 2 wetlands that are a bit far from the Beg River. We also did some sediment sampling. And then looking at the results of the sediment column test, we realized that the 2 wetlands that are basically very close to Beg River on the floodplain, they have very slow infiltration and they have a clay-rich top layer. But the other 2, they have fast infiltration rate when dry, but when they are fully saturated, then the infiltration becomes slow, I think. Yeah. And then on the hydrochemical analysis, which is the last component of the assessment, we basically took some samples from the boreholes, from the piezometers, from the wetlands themselves, and from the Beg River. And we also had one or 2 rain gauge where we actually took some samples from there. So with the field measurements, again, we did pH, EC, dissolved oxygen and temperature. And then with the lab measurements, there was an analysis of the major ions as well as the isotopes. So we basically used a BioGrip lab for the analysis. Sure, I'm almost done. For the analysis, but for the sake of this presentation, I'm only looking at the major ions. So we also did some Piper diagrams where we realized that during wet seasons, I think I didn't mention that with the monitoring, we started monitoring beginning of 2022, which was March 2022 until March 2024. So it was over a period of 2 years. So with the wet season, there is moderate EC levels reflecting recent recharge and dilution from rainfall. And then with the dry seasons, we realized that the water type becomes more of sodium chloride water type, especially in the wetlands and groundwater. So all these points, they represent wetlands, the boreholes where we took the samples, as well as the Beg River water. So we basically attributed that with the dry seasonal hydrogeological stress, and also the increase in the EC highlighting elevated salinity. So in conclusion, as much as we analyzed all these, or we monitored all these 11 wetlands to get a baseline and input into the monitoring protocol, but we also realized that using this index, it's very good if you are a non-wetland specialist. It gives you a very good overview of how the wetland is, what's the status, and which class it falls into. However, when there is no open surface water present in the wetland, then the chemistry cannot be assessed and the index actually fails to classify. So we sort of need to find another way to classify the wetlands that were dry. Also, the wetlands are moderately and lightly modified. Therefore, introducing MAR, you basically need to understand the water type that you're going to introduce, so that it does not make these even worse, because already they are moderately and lightly modified. Instead, it should be a recovery of these. They should benefit in recovering these wetlands. And also the risk of MAR in Langebaan Road Aquifer includes raising the water table in sensitive wetlands, and because those wetlands are discharge zones. So you basically need to avoid flooding the system. And yeah, the wetlands can be used as environmental monitoring points, and we do recommend that there should be a continuous monitoring of those wetlands, just to understand their state, and then you can sort of come up with a way to see how MAR can impact them. So yeah, I think that's all from me. Thank you so much. On the other work packages, you can get some of the deliverables using that link. Thank you so much.
Thank you. Thank you very much for that presentation. Now I will ask you for any questions for her before she takes her seat. Yes, sir.
Hello. Thank you very much for your presentation. I'm particularly interested in the hydrochemistry with the monitoring perspective. Do you measure or monitor the same parameters in all of the managed aquifer recharge areas, or do you place special emphasis on this area? Maybe we look at this one and that area. And if you can highlight a little bit also, like how dissolved oxygen informs the results of your study. Is it from a compliance perspective, public health perspective, or is there another reason? Thank you.
In the interest of time, allow me to take another question, if there are any. I've taken notes for you to remember. If there is none, I think I'll give you the chance to respond.
Okay, if I understand you correctly, you're saying if we're monitoring the same parameters in MAR sites or the wetlands? MAR.
If you're monitoring the same throughout, like you measure maybe iron or you calcium, you mentioned also sodium and chloride, do you measure the same chemical parameters in all of your study areas, like over the years and the sites?
Okay, okay. Let me first say, with the MAR sites, obviously they're measuring different parameters depending on where the site is. For example, with the Atlantis site, they would basically measure different parameters from the site that is in Polokwane. But with the wetlands that are presented in this study, the 11 wetlands, we measured the same parameters, okay? And I think, what was the next one? Oh, with the dissolved oxygen, we basically realized that in wetlands that have flowing water, there is high dissolved oxygen. If I'm not mistaken, I think my partners who were part of the study can add on to that. But some of the wetlands, we realized that the water had been standing, had been there for longer, especially in the wetlands where the infiltration rate is very low. Because during dry seasons, then the wetlands, they depend mostly on groundwater. So if there is a flow, that's how we actually saw the influence of dissolved oxygen. But again, with the analysis that were done at the lab, looking at the major ions in all the wetlands, you realize that during dry seasons, the wetlands, they become, the EC levels during dry seasons, it becomes high. And during wet seasons, which is winter, it becomes diluted. So it becomes very low. So we basically look at all the parameters mainly to get a baseline so that when now you start implementing MAR in that study, you sort of understand what was the status of that wetland before you introduced MAR, especially because you're looking at different sources of water, the other source of water being water from the Berg River, and another potential source of water being treated wastewater. So you try to get a baseline, like a very basic baseline of the wetland, because they were not monitored. We didn't have any data before. We tried to get data using this research project. So I think it was mostly on the baseline conditions of the wetlands. Yeah, thank you.
I want to assume that you have asked a question for everyone. Ma'am, I want to thank you for your presentation. Can you put our hands together as she sits down?